So I'm going to talk about testing that you can do in an open air house and see what kind of results come about when we have OFDMA and MU-MIMO in the mix. The tests that I'm going to review today, they involve off-the-shelf stations and APs. So what I did was I got a 11AX Asus high-end router, and I got 4 Galaxy S10 Pluses, and we're going to test those using 5 different Wi-Fi modes. We're going to use 3 different station configurations. So that means we're going to use a test where we're going to test just one client by itself, which is the way we usually do house testing. Then we're going to do a 2-client test and then a 4-client test. The house is going to be used for 3 different links. We've got line of sight link. We've got a line of sight adding some attenuation. And then we have an actual mid-range test where we scatter the clients throughout the house. Now, these tests are all being run on channel 157 with an 80 megahertz bandwidth. All the traffic is downlink, TCP, Chariot, and we're going to use just one turntable. We're just going to rotate the AP. So the 5 different modes are mixed between Wi-Fi 5, so 802.11 AC. We're going to test AC without MU-MIMO and with MU-MIMO. So there's 2. And then the other 3 are Wi-Fi 6 just by itself. Then we're going to add OFDMA. And then the 5th Wi-Fi mode we're going to test is going to be Wi-Fi 6 with OFDMA and MU-MIMO. The Galaxy S10s are not being reconfigured. They're just reassociating when you change the mode on the AP. The nice thing about this Asus AP, just out of the box, there's Telnet enabled. You can go in, you can use the Broadcom WL commands. You can verify that you actually have OFDMA turned on correctly and MU-MIMO is enabled. So I was able to do that pretty easily. The AP, you can see here in the photo, I did sort of a vertical antenna orientation, but I turned the 2 outside antennas at 45-degree angles to try to help with the sort of spatial diversity to make sure I was getting the best phi rates possible. The 4 Galaxy S10s are just sitting on a turntable at the same height on a ABS stand that angles it at about 60 degrees. So I am using Chariot, which everybody's been using for quite a long time to run these tests. We're doing a 60-second throughput test at each orientation of the turntable, and we're throwing out the first 15 seconds, and we're just using the average from the last 45 seconds of the test. So in case there's any ramp up, we're sort of negating that from the averages. What I'm also doing is I'm sampling the RSSI of each one of the Galaxy S10s during the initial 15 seconds of that throughput test. Using ADB, we're SSHing in and we're querying the RSSI so that we get an accurate RSSI measurement of each one of the clients. We get it 12 times around the turntable, and we average that together as well. So the traffic station configurations, again, is 1 station downstream TCP to stay 1. We're using 8 Chariot pairs, so we're using the same number of Chariot pairs for all these tests, regardless of the number of stations, just to try to keep things consistent. Then we do 2-station tests where we're using station 1 and station 2, and those are, I'm doing my best to keep those on opposite sides of the AP to try to help MU-MIMO do the best work that it can do. And then the 3rd configuration, where we're just using 2 spatial streams 2 Chariot streams to each one of the clients, is the 4-client configuration. And those I'm trying to keep separated as best as I can in sort of 4 unique quadrants, again, to help MU-MIMO do its best work. So these tests are all being run in a large home that has really good isolation. No concerns about 5 gigahertz interference here. So this photo is showing what the line of sight and the line of sight with attenuation link looks like. So this is 2 of the 3 links that were tested here. So you've got the AP in the middle, and then you've got the 4 phones at about 5 feet distance from the AP at 90-degree angles. The attenuated link is I took some fixed attenuators. I inserted them between the dipole antennas and the actual AP itself, the SMA connectors. And the thinking there was let's simulate some range, but let's keep this ideal sort of spacing of the clients, again, to help see what MU-MIMO could do in sort of a perfect world. Turntable in the center is rotating clockwise, with the orange arrows there for. So the turntable is static during the throughput test. After the throughput test is done, it rotates 30 degrees, and then the next throughput test is run 12 times. So the third link configuration is where we had to move the AP. We couldn't leave the AP where it was and get configure the clients equally around the AP, because you would have had to move outside to do that. So I found a spot in a smaller bedroom to place the AP, and then was able to find, through a fair amount of work, wasn't easy, locations that had equal attenuation throughout the house that sort of gave me the best. It's not 90 degrees. They don't have as much isolation as they did with respect to each other before, but it's the best I could do given a limited amount of time. I wouldn't want to have to do this on a regular basis and try to find different links where all the clients had similar RSSIs. There's just photos of the mid-range setup of the devices spread throughout the house. Here, I want to just show the RSSI measurements before we get into the throughput, just to show you, give you a feel for each link. So the line of sight link at 5 feet, basically all 4 clients are around negative 30 dBm. And then when you add the fixed attenuator, they're all around minus 50. And then in the mid-range, when you're actually spreading them throughout the house, you're around minus 60 dBm. Okay, so the first one is like the straightforward test that we've all, I think most people have done or they've seen results, is just one station, Wi-Fi 5 versus Wi-Fi 6. So OFDMA and MU-MIMO are not in play here, but we just want to just make sure that we're seeing data that makes sense to start with. So at line of sight, we see a 25% throughput increase when we go from Wi-Fi 5 to Wi-Fi 6. So that PHY rate is going from 866 to 1200, and the throughput's about like 75% because we're using a TCP script here. So you get a 25% boost in throughput with Wi-Fi 6, and then as you add attenuation, increase the difficulty of the links, that advantage of Wi-Fi 6 diminishes. I think if you went out even further to long range, you'd see very little difference. Tying this back into a rate versus range slide that Lee showed earlier, Wi-Fi 6 versus Wi-Fi 5, these data points actually line up really well with the octoBox results, even though they're different clients. You know, we're using Broadcom. This test here is a Broadcom 4x4 AP and Broadcom 2x2 Galaxy S10s. But just turns out coincidentally that the differences in Wi-Fi 5 versus Wi-Fi 6 line up really closely here between what you get in the octoBox and what you get in the house. Okay, so looking at the 2-station MU-MIMO for Wi-Fi 5. So I wanted to start out by seeing how well does MU-MIMO work for Wi-Fi 5 before we look at Wi-Fi 6 and MU-MIMO to give us some context. So it's a mixed bag. You get a little bit of a boost line of sight and with attenuation, but once you go into sort of you're spreading devices throughout the house, the test I ran actually showed a decrease in aggregate throughput for 2 clients. That reminds me of, so Tim Higgins did back a couple of years ago, he did a review of MU-MIMO Wi-Fi 5 and he called MU-MIMO the 3D TV of Wi-Fi. And I think this illustrates the point here. So if we look at the 2-station configuration now with Wi-Fi 6 and MU-MIMO enabled, the difference is much better. It's consistent across all 3 links. You get a 25% increase in throughput for 2 stations with Wi-Fi 6. So that's good. And if we look at the step chart or the throughput around the turntable graph, what you see, I've added in the orange bar line is with OFDMA versus with no OFDMA for 2 stations. You see no difference, but you do see a consistent improvement in throughput with MU-MIMO enabled. Okay, so now we're going to move up from 2 stations to 4 stations, and we're going to look at Wi-Fi 5 and see what it does. So Wi-Fi 5 with 4 stations, line of sight, it does pretty well with MU-MIMO enabled, 70%. Now, like on an absolute basis, it's pretty good. I think what you would read in marketing literature is you're supposed to be getting like 3x increase in throughput with MU-MIMO. I think those were the claims back when it came out with Wi-Fi 5. So we're not getting anywhere near that, but we are getting a significant throughput increase with 4 stations. Same thing with the fixed attenuation, but when you go to a mid-range, like a more of a real-life scenario, you get a little bit of an increase, but not much, 20%. However, for Wi-Fi 6 with 4 stations, no MU-MIMO versus MU-MIMO, we're seeing about 80% increase at all 3 locations. So again, similar to what we saw with 2 stations, but we're seeing even a bigger boost in aggregate throughput, and it's consistent. So to wrap it all up, for the 4 stations, if you compare MU-MIMO Wi-Fi 5 versus MU-MIMO Wi-Fi 6, you see that Wi-Fi 6 MU-MIMO is between 20 and 65% better for this configuration across all 3 links. And finally, just to try to tie things back into what Lee was talking about earlier about having to run tests differently if you're trying to assess OFDMA. If you're just looking at the difference between Wi-Fi 6 with OFDMA and Wi-Fi 6 without OFDMA for these tests, there's really no difference when you're running downlink TCP traffic, kind of the old school testing methodology that we've all been doing for 10 plus years. There's really very little difference in throughput that OFDMA is adding without MU-MIMO. Having said that, though, at mid-range, if you look closely at the step graph, there is a 7% gain that you get with OFDMA on. And you can see it's most of the orientations around the turntable, it is better with OFDMA on, but I wouldn't want to have to try to prove this on a regular basis. Open air testing, usually you're looking at a plus 15% error, right? So to try to see a 7% gain for OFDMA, I think would be kind of a waste of time. I wouldn't want to be tasked with that. So while I'm running tests, I look at Channelizer for MetaGeek, try to make sure that everything's, I'm on the right channel and there's no interference. And I noticed something interesting in the spectrum. So the bottom part of this capture here is a waterfall view showing the energy over time. And so the way that the tests were run were sequentially, I would run 1 station at orientation 0 degrees, and then 2 stations, and then 3 stations, and then the turntable would rotate, and then I'd repeat over. So what you can see there over time is that at the bottom of the graph is a 1 station test where the energy across the 80 megahertz being tested is continuous. But when you go to 2 stations, you see a notch in the middle, and the same thing for 4. And then when you go back to 1 station, that notch disappears. It turns out that is actually OFDMA working. So it's another visual way to verify without a sniffer that OFDMA is actually being utilized. So there's a notch in the middle of the 80 megahertz band that's present when you're running, I think, 2 or 4 different AIDs, something like that. And to summarize the results, just to go over all this stuff, is so Wi-Fi 6 MU-MIMO, it does increase capacity significantly with 4 stations. Now, significantly is 80%. That's not, I think, what you're going to see marked on a box at fries, but still pretty good. It works better. Wi-Fi 6 MU-MIMO works better than Wi-Fi 5 MU-MIMO for this setup. And the other takeaway is OFDMA doesn't increase TCP throughput. So you're not going to want to test OFDMA with TCP throughput downlink. And that was verified with 1, 2, and 4 stations.